Imagine that tomorrow, scientists announce they've found life on Mars. Not intelligent life, not a signal from the stars, just microbial bacteria frozen under the Martian surface, alive. Most people would celebrate. It would be the greatest discovery in human history. Proof that we are not alone. It would also be, according to some of the most serious thinkers in science, the most terrifying thing that has ever happened to our species. That's not a hyperbole. That's the logical conclusion of an idea that has haunted physicists, biologists, and philosophers for 70 years. An idea so unsettling that the more you understand it, the harder it becomes to sleep. It started with a lunch. It was 1950, Los Alamos National Laboratory. A group of physicists sat down to eat, and the conversation turned to a cartoon in the New Yorker about flying saucers. Someone made a joke. The others laughed. And then Enrico Fermi, one of the greatest scientific minds of the 20th century, went quiet for a moment. He looked up and said, "Where is everybody?" Those three words became one of the most profound questions in science. Fermi had done the math in his head. The universe is roughly 13.8 billion years old. Our galaxy alone contains somewhere between 200 and 400 billion stars. A significant fraction of those stars have planets. Many of those planets orbit in the habitable zone. Not too hot, not too cold. Even if only a tiny fraction of those planets developed life, and an even tinier fraction developed intelligent life, the galaxy should be absolutely full of civilizations. Some of them should be millions of years more advanced than us. Civilizations that old would have had time to colonize the entire galaxy multiple times. And yet, silence. No signals, no probes, no visitors, no signs of megastructures reshaping distant suns. Nothing. The sky is silent in a way it simply shouldn't be. That gap between what the math predicts and what we actually observe is the Fermi Paradox. Physicists have proposed dozens of explanations. Maybe the distances between stars are simply too vast, and no civilization has ever managed to cross them. Maybe they're out there, but using communication methods we can't yet detect. Maybe they're deliberately hiding, watching us the way we watch animals in a nature reserve, careful not to interfere. Or maybe, and this is where it gets dark, they're simply gone. In 1998, an economist named Hanson published a paper that reframed the Fermi Paradox into something far more personal. His argument was straightforward. If the universe is old enough, large enough, and the conditions for life are common enough, then the absence of any visible civilization means something is stopping them. Some process, some barrier that civilizations reach and cannot cross. He called it the Great Filter. Think of it this way. Imagine all the steps required to go from empty rock to a civilization capable of leaving its own galaxy. A biogenesis, the first spark of life from chemistry. Single-celled organisms developing into complex, multicellular life. The emergence of intelligence, the development of technology, and finally, the ability to survive that technology. Each step is improbable. Multiply enough improbabilities together, and you get silence. Somewhere in that chain, there is a filter, a bottleneck so extreme that almost nothing gets through. The question, the only question that matters, is where it sits. There are two possibilities, and they lead to very different conclusions. The first possibility is that the filter is behind us, that one of those early steps, perhaps the leap from chemistry to life, is extraordinarily rare. So rare that in a galaxy of 300 billion stars, it has only happened a handful of times. Or once. If that's true, then we are the improbable ones. We already passed through the needle's eye. The silence isn't a warning. It's proof that we somehow survived the hardest part. The second possibility is that the filter is ahead of us, that life is actually common, that planets develop bacteria, and bacteria develop complexity, and complexity eventually produces something that looks up at the stars and asks questions. That all of this happens regularly in millions of places across the galaxy. And something kills them every time. Nuclear weapons, climate collapse, a pandemic engineered by accident, an artificial intelligence that outgrows its creators in the span of a decade. Something we haven't thought of yet. Or something so obvious that every civilization eventually discovers it and never survives what comes next. This is why finding life on Mars would be catastrophic. Not because Martian bacteria are dangerous, not because it opens a door to something threatening, but because of what it implies about the filter. If life exists on Mars, even simple, ancient microbial life, it means that the emergence of life is not extraordinarily rare. It means life is something the universe does regularly, given the right conditions. It means that early step, the one we hoped was the filter, wasn't the bottleneck at all. Which means the filter is still ahead of us. Look at the century we're living in. We have nuclear weapons capable of ending civilization several times over. We are altering the climate of our own planet at a speed that outpaces our ability to adapt. We are building artificial intelligence systems whose behavior we already struggle to predict at a pace no regulatory body on Earth fully understands. Each of these could be the filter. The unsettling thing is that every civilization that reached our level of development probably felt the same way we do. Capable, progressing, perhaps uniquely positioned to survive what previous civilizations couldn't. The silence suggests they were wrong. Here's what makes the Fermi Paradox genuinely unresolved. Not just philosophically, but scientifically. We have one data point, our own civilization. One sample is not enough to draw conclusions about a universe with 300 billion galaxies. Maybe there are signals we haven't found. Maybe the galaxy is busy in ways we can't yet perceive. Maybe the silence is temporary, a matter of our limited instruments and our brief 70 years of serious listening. We simply don't know. But the logic of the great filter doesn't require certainty. It requires only that the question be taken seriously, And right now, it isn't. Not at the scale it deserves. Enrico Fermi asked his question over a lunch that lasted less than an hour. He probably didn't expect it to still be unanswered 75 years later. We've mapped the human genome. We've built machines that beat us at every game we've invented. We've landed vehicles on Mars and sent a probe beyond the boundaries of our own solar system. And the sky is still silent. Maybe that silence is a gift, the universe giving us time to grow up before we join it. Maybe it's a warning left by civilizations who didn't make it, a message written not in radio waves but in absence. Or maybe it means nothing at all. The most honest thing science can say, 75 years after Fermi's question, is this: we don't know which possibility is more frightening, that we are alone in this universe, or that we are not.